Hello guys, welcome to Holodeck. Today we are going to solve the lead code problem number 100. It is a problem statement says like we need to find whether the two given binary trees are identical or not. So as you can see, it's an easy problem and it is a self-explanatory. What we can do, we can discuss about like different approaches to solve this problem. As we know, there are like most commonly used approach to solve the binary tree problems are like either recursion or maybe a traversal, right? So we need to decide which is the best traversal mechanism to solve this kind of problems, right? So as you can see, when they are saying like about the tree levels, right, basically the nodes are identical or not, correct? If they're we need to check the levels are identical or not, then definitely we can go for a level at the traversal of a binary tree and check like level by level or they are matching. Anywhere if you find it is not matching, we can return it as a false. Okay, this is the level at the traversal approach, but there is another approach. But before jumping to another approach, I wanted to tell you about like what is the space complexity and the time complexity which is going to take for the level order traversal. Okay, so as you can see, we need to store each node, correct, in the queue, and root node if you store it, and we have to iterate through the queue and add each node to the queue and find whether each node are matching with the respective another tree nodes. If it is not matching, we need to return it as a false, right? So basically we are taking it as a true two queues to store this node values, right? And definitely when we are taking two nodes and each node value in the values from the both the binary trees are stored, correct? So it's definitely the size of the queue in the to store each tree is like O of n of, say for example, this is of size n and this is of size m. So it going to take O of n, okay, O of n for this approach, for this tree space complexity, and O of m for the second binary tree. Okay, so this is a space complexity. How about the time complexity? If you talk about a time complexity, so we are going to iterate either one of the binary tree. It's not compulsory we have to iterate through both the things, right? If you have one tree and anywhere if you found one is has a highest depth than the other tree, so even though if it is not identical, definitely we are going to return false at that moment itself. Okay, and coming to the time complexity, so if it is of size n, so we have to iterate O of n time. Okay, and if this is of size m, we have to iterate through the m nodes to find the nodes are identical. So this is the space complexity and this is a time complexity. Cool. Now let's jump into the another approach. I will just give you an explanation about what is that recursive approach to solve this problem, right? So how are we going to solve that? So let me take a marker so that you guys can easily understand it. Cool. Now in case of recursive, what we do, we are not going to store any values. Okay, we are going to iterate through each nodes. Okay, and anywhere if you find, say for example, we start from the root node, okay, and we match it whether they are identical. If not identical, we immediately return it as false. Okay, and if it is identical, we go to the left of the first binary tree and the left of the second binary tree, and again we check it. If it is written if not identical, we return it as false. And once we done with the left nodes, and we go for the right nodes, are they identical? If they are not identical, immediately we return it as a false. Okay, this is a simple approach and we don't need to write a much code here, just like a 2 to 3 lines of code to solve this problem. Okay, and coming back to the time complexity with this approach is definitely, as you know, like we need to iterate through all the nodes, so it will be definitely O of n times for the first tree, right? And yeah, whichever smaller, for that much size we are going to travel. right, for throughout the nodes. If for example say like the second binary tree size is like more than the first binary tree, so definitely we are going to travel the whichever the size is less, and we not going to travel beyond that, correct? So in that case, the worst case I can say like O of n for the first and O of n for the second binary tree. Okay, and the space complexity, definitely we are not storing any values, it will be a linear time complexity. Cool, this is the approaches. Now let's jump into the code. Now I will start with the recursive approach to write the program for this. So what we do, let's take the base condition here. If p equals to q, we should return it as true. Okay, and if p dot val is not equals, sorry, this is p, right? Q dot val, right? If it not return, we should say it as false. Cool. So this is the base conditions, and we need to iterate, correct, throughout the array. So what we should do, we should take the left nodes first, or we can start with the right node also, it doesn't matter. Okay, p dot, I'm starting with the left node here, q dot right node. Okay, and also we should start with the right node as well, is same. Okay, that is p dot right, sorry, this should be left, right, and q dot right. So what we did here, basically we took, let me take another color for this, let's say blue. So we took the left first here, okay, sorry, not this one, this one. We took this two nodes first, then we took the right nodes next, and we comparing both the things. If they are true, it goes, if not, it immediately returns as false. Okay, now let's see if there are any syntactical errors. No, right? Now submit this code. Cool, this is a very simple 3 lines of code. Now let's jump into the level order traversal approach. So what we do in the level order traversal, again here we need to do a base check here. If p is equal to now, p is equal to q, I can return it as true immediately. So these are the base conditions we are checking. So what we do next, somewhere, say for example, if p is not null, okay, p equals to not null, okay, we can check this later also, that's not a fine. P dot data, that is val, right? P dot val not equals, if there are only one nodes and the node value is different, right, immediately we can return it as false. And q dot val not equals to, so not null, basically if it is not equals, both are not equals, so basically we can return it as false, the first node value and the second node value at the root. Okay, if they are not equal, we can return it as false. What we do next, so basically we should take a two queues to store this node values, right? I can name it as var q1 first, I can say this q1 is equal to linked list of tree node, okay, and q2 is equal to linked list of tree node. This is the second tree we are going to store in it. And what we do next, we need to add a level order traversal. Very simple. Okay, we need to add first tree to the q1 and second tree to the q2. And what we do next, we need to iterate through the queue to find and check whether the each nodes are equivalent. Okay, what we do now, q1 is not empty and q2 that is not empty. Okay, here also things, if both are not empty we have to poll that. Okay, where I can say node 1, okay, q1 dot poll, we took the first node from the queue, from the q1, and also I can say node 2 for the q2 dot poll. Okay, and we need to check if these nodes are equal or not. Node 1 dot val is not equals, directly we can say it is not a valid identical tree. Okay, now return it as false. This is supposed to be 2 and this is supposed to be 1. If not, right, if they are identical, what we should do, we should check node 1 dot let and node 2 dot let. We need to add the every node to the queue. So this is about node 1 as tree 1, right, and q dot add node 1 dot, so basically I can say it as a root 1 instead of oh yeah, I can say it as p is added, q is added, right. Okay, p1 I can say it's easy to understand, let it be. So let's not consume more time over here. Let's take this one, node 1 dot I can say it dot left. Okay, and q of q2 of it dot right. Okay, we are keep adding them, and on every each iteration, as I'm saying, on every each iteration we are going to check the values here. Cool, in this we are checking it. If it is false, we return it as false. If they're not equal, we are return it as false. If they are equals, right, we are going to add all the nodes. Okay, now let's move back to the code. When they are equals, both the queues become empty and we can return it as true, right. If not, definitely it will going to return it as a false. So it's saying something wrong in the code. Okay, let's check it. What is the mistake we heard it here? Oh yeah, we need to add even left and right also, correct. It dot I can say it something like so we need to add it dot right also, and here also q2 dot add it dot left. this is left and this is going to be right. Okay, now run the code. Let's see. Basically we are comparing both the values here. Somewhere if it is false, basically it will return it as a, if it is not equal, it is going to return as a false. And yeah, so it works fine. Let's submit the code and see all the test cases passes. So already explained you the time complexity and space complexity of the both the approaches. So yeah, that's it guys. Thank you so much for watching. For more such videos, please do like and subscribe, and stay tuned for the next videos.